All right, today we're tackling a topic that software developers absolutely love to argue about: design patterns. Are they these brilliant blueprints for building great software, or are they basically just warning signs that your programming language is missing something? Let's get into it.
I mean, you've probably seen it, right? Go on any programming forum, and you'll find these epic debates that have been raging for years. So what's the deal? Why do these things called design patterns stir up so much passion and, frankly, so much disagreement?
Well, to really get it, you got to go back to the beginning. And the funny thing is, the whole idea of patterns had nothing to do with code initially. It all started with a really simple question about how experts in any field get so good at what they do.
Yeah, this is really the whole idea in a nutshell. Experts, no matter the field, they don't reinvent the wheel every single time. They recognize a situation they've seen before, and they reach for a solution they already know is going to work. The goal of patterns was just to capture that expert thinking and make it available to everybody.
Okay, so you take that idea, capturing expert knowledge, and you apply it to the world of software. And that's how we get to the official story of what we now call design patterns.
Now, it's really important to get this straight. A design pattern is not a finished chunk of code that you can just copy and paste. It's much more like a blueprint. It describes a problem you'll see again and again, and then it sketches out the core of a solution that you can then tailor to your own specific program.
This whole concept really got cemented in place back in 1994 with this one, legendary book. It was written by four guys: Eric Gamma, Richard Helm, Ralph Johnson, and John Vlasides, who pretty much instantly got this cool nickname, the Gang of Four. Their book laid out 23 classic patterns and, in the process, created a whole new language for talking about software design. So, to make sense of all these patterns, the Gang of Four split them into three big buckets. First, you've got creational patterns, which are all about, you guessed it, how to create objects effectively. Then there are structural patterns, which deal with how you piece classes and objects together into bigger, more useful structures. And finally, behavioral patterns, which are all about how different objects talk to each other.
All right, enough theory. Let's talk about something real, a feature you and I use every single day, that undo button. Have you ever stopped to think about how that actually works? How does a program remember the state it was just in so you can go back?
Well, a classic pattern for this is called the memento pattern. Here's how it goes down. First, the originator, that's our text editor, takes a snapshot of its current state. Second, the caretaker, that's our undo history, grabs that snapshot and just holds on to it without messing with it. Finally, when you hit undo, the editor just asks for that snapshot back and restores itself. It's a clean, simple way to handle a complex problem.
Okay, so patterns seem amazing, right? A genius way to share expert knowledge. But just as they were getting super popular, the whole story took a twist, kicking off a massive debate that's still going on.
Yeah, I mean, the ink was barely dry on the book, it was flying off the shelves, and already a really strong counter-argument started popping up. What if these patterns weren't timeless pieces of wisdom? What if they were actually a sign of a problem?
And that entire counter-argument was captured in one single, absolutely devastating quote from the legendary computer scientist Peter Norvig. He said, "Design patterns are bug reports against your programming language." Ouch. His point was that you only need a pattern when your language isn't powerful enough to solve the problem directly.
And this gets to the very heart of the whole debate. Remember, the Gang of Four based their book on languages from that era, like C++ and Smalltalk. The criticism is that many of those famous 23 patterns are just clunky, complicated ways to do things that a more modern, more expressive language can do in a single line. So the question becomes, are you really solving a clever design problem, or are you just fighting your tools?
All right, to really see what this argument looks like in the real world, let's put one of the most famous, and let's be honest, infamous patterns under the microscope, the singleton.
On the surface, the idea is super simple. The singleton pattern just makes sure you can only ever create one instance of a particular class. For things like a central configuration manager or a single database connection, stuff you definitely only want one of.
So in the early days, writing a singleton seemed easy. You'd just check if you already had an object, and if not, you'd create one. Simple, right? But there was a huge flaw. In a multi-threaded world, two threads could check at the exact same time, both see, nope, no object yet, and both create one. And poof, Your singleton is no longer single. And trying to fix this? Oh man, it led programmers down this rabbit hole of unbelievably complex solutions. People were getting lost in the weeds with things like double-checked locking and memory models. The code got ugly, hard to understand, and super easy to get wrong. It was a classic example of developers writing tricky code just to make up for what the language couldn't do easily. And then a much, much better solution showed up. And guess where it came from? Not from a more complex pattern, but from a core feature of the language itself. In Java, it turned out you could use a simple single-element enum to create a perfectly thread-safe, guaranteed single instance in just one line of code. The language grew up, and the complex pattern just melted away.
And this simple, elegant solution was made famous by none other than Joshua Bloch in his Bible for Java programmers, Effective Java. He declared it the best way, period. And for Java developers, that was pretty much the end of the debate. This was a massive win for the patterns are just language bugs camp.
Okay, so if a new language feature can just wipe out a complex pattern, does that mean they're all useless? Well, not exactly. And this brings us to how we really think about their value today. It turns out the real superpower of design patterns isn't the code itself, it's the communication. It's about having a shared vocabulary. When you can say to another developer, I'm using a factory here, they instantly get the idea without you having to explain every single line. It lets us talk about big ideas, quickly. They're not a strict set of rules you have to follow. Think of them more like a dictionary of powerful concepts you can draw from.
So if the best patterns just end up getting absorbed into our tools, what does that mean for us right now? Where are we headed?
And this is the final kind of beautiful twist in the story. A lot of the classic patterns, like the iterator pattern, they didn't fail. They won. They were so incredibly useful that they just got baked right into our programming languages and libraries. We don't think of them as patterns anymore. They're just part of the landscape. Their very success made them invisible.
And that leaves us with one last big question to chew on. That original design patterns book is 30 years old now. The software world we live in is completely different. It's all about microservices, cloud computing, reactive systems. So the real question isn't whether patterns are good or bad. It's this: what are the essential solutions we're discovering right now? What's the book that the next Gang of Four ought to be writing today?